Okay, we're in section 1 of the notes, and we just covered this material here. Hopefully you paid attention. You have some understanding what's been presented to you, and you're thinking about how this is going to be, what the questions are going to look like. Again, we went through a lot of material. I know that. And again, we're hoping that you paid attention. And again, you had some understanding of the material that were presented to you. Like, I'm not going to say perfect, but some understanding. Of course, you need to go back over that periodically to make sure that you understand that. All right. Now, what we're going to do is we're going to do the example. So we're going to reinforce what was just told to you by doing examples. After we go through these examples, though, and we'll go through each one separately, it'll be lecture format. All right. Now, of course, when I say it's lecture format, you may decide that you want to start doing them yourself. You got to get through this material, though. Once you get through these first 10 problems, and I'll do this together with you, you're going to be working on this thing independently. All right. The supplemental stuff. But anyway, I'm going to go to the whiteboard, and I'll do the whiteboard. I'll just do the examples, and we'll talk through it as it pertains to what was presented in class. All right. So let me switch screens. And the expectation is that you're able to, listen, try to make sense out of what's being presented to you, and then certainly do it independently of me at some point. That's what we're hoping for. All right, so give me 1 second. I'm going to share the whiteboard with you. This will be a typical format of the course, by the way. Okay, so the first thing I want to do is just talk about, problem number 1. All right, so in number 1, you read it, and certainly as I read this to you, I want to make sure you understand what we're going to do. First, we read it. Do we understand what we've read, and can we answer their questions? Right. So it says take theta to be 0 degrees. So the first thing I would do over here is I would just draw a picture, or at least I'd attempt to draw a picture of what that would look like to me. All right. So what I'm going to do is I'll draw my initial side, and then I'm going to rotate the terminal side 0 degrees, and that means it hasn't moved. It's on top of that. All right, so I got that covered. It says, so take theta to be 0. Let me write that down. So theta is equal to 0 degrees. I'm going to say that's 0 revolutions, right? Or I could just simply write that number 0 down, indicating 0 radian. Radian is a unitless measure. All right. And of course, what do they want me to do? They say first draw a picture of a unit circle. Well, I'll do that. I didn't do that yet. And this is centered at the origin. Not a great picture. It doesn't have to be. So then it just determine what x, y, and r are for this particular picture. Well, the point's here. This is the x-axis, and this is the y-axis. So let's write this down. What would x be? Well, if it's a unit circle, x would be 1. Unit circle is a radius of 1. What's y going to be? Well, looking at the picture, the y is 0. And what's r? Well, though it's a radius of a circle, it's 1. All right. The next thing they say is evaluate the sine, the cosine, and the tangent of theta. Let's write these down for you. The sine of theta is defined as being the ordinate, which in this case is y, over the radius r. The cosine of theta is defined as the abscissa, in this case it's x, over r. And the tangent of theta is going to be defined as the ordinate, again, which is y in this example, over x, which is the abscissa. I think I can put that down now. So let's write this down for you. So, if I know x, y, and r, let's write this over here. Sine of theta, and again, theta in this case is 0 degrees, is going to be y, which is 0, divided by 1, which is 0. The cosine of 0 degrees, whoops, I put theta down, didn't I? Is going to be x over r, that's 1 over 1, which is just 1. And the tangent of 0 degrees is going to be y, which is 0, divided by 1, which is the radius, which will be 0. Okay, I want to point out, a lot of times people lose the question when they don't take notes. It's probably a good idea to take notes. Right? I'm going to say we have our picture drawn. let's look at this. I have this written down, x equals 1, y equals 0, 1, 0, 1, 0. All the answers are written down for you. Let's go to the next question. Again, as you're looking at these things, you might say, so let me give it a try. We want you to try. Let's put this down. So it says, find the point x, y in the unit circle. And let me just put this over here. I'm going to put the unit circle down now. And a unit circle, again, I'm not going to say it's a great picture, but that's my unit circle. It's a circle, radius 1, centered at the origin. Now they say that it corresponds now, they're not using theta, they're saying t. And t equals pi over 4. Well, pi over 4, I'm hoping you're more familiar with this at this point, is going to be 45 degrees. Or it's going to be 1/8 of a revolution. Let me just briefly go through that with you. Pi over 4 times, well, the conversion factor is going to be, there's 180 degrees in every pi radian. If you do the arithmetic over there, the pi's would cancel, and 4 goes into 180, 45 degrees time. All right, so if you want to convert it to revolutions, let me put that down for you. This would be pi over 4 times, well, there's going to be 1 revolution in every 2 pi radian. If you simply simplify that, the pi's would cancel out, and you're left off with 1/8 rev. All right, let me draw a picture of that. I'm going to put down the initial side, and the terminal side I rotate 45 degrees. So roughly speaking, looks sort of like this over here. There'll be a point here that I'm very concerned about. Now remember, there's a couple different triangles to remember, and one is a triangle that has a reference angle of 45 degrees. So let me just draw that reference triangle out for you. And we've talked about this, and I'm going to say it's a 45, 45, 90. And yeah, certainly there's various ways of putting that down, but most people put this down for it. But you can scale this dividing all the sides or multiplying all the sides by some non-zero number. If I divide by root 2, I would say I'd get something different. And again, we have discussed this in lecture. I'll get my eraser out, erase this. I can divide the sides by root 2. Someone says, why would you do that? I want the radius to be 1. Whoops, sorry about that. I didn't mean to do that. Your objective here is to visualize this as being a triangle with a reference of 45 degrees. This is 45 degrees. All right. What do you mean by reference triangle? There's a triangle in here that refers to that. And so what's the point going to be? Well, the x-coordinate would be 1 over root 2. The y-coordinate would be 1 over root 2. And the radius would be 1. All right. There's my little picture. All right. It takes some time to get that down, but we want to encourage you to take the time to do that. All right. So it says, find the point. Well, I did find the point. The point is 1 over root 2, comma 1 over root 2. All right. Some students are disturbed by that because they were told in Math 100 their teachers didn't like them writing that down. I don't mind it though. And teachers told them that you got to write this down instead. I got to tell you, I think 1 over root 2 looks better than root 2 over 2, but they're identical numbers. So I'm going to write that down for you. 1 over root 2 is identical to root 2 over 2, but I like 1 over root 2 better. So I found the point. So certainly I'm looking at my picture, I found the point. I know the number t is 45 degrees, pi over 4, or 1/8 of a revolution. It says use this to evaluate the sine of t, cosine of t, and tangent of t. Notice that I'm using the letter t for the angle now. And you should get more comfortable with various letters, including we might use x and y for that. All right, you have to be clear about that. So this is my second problem in the examples, and I think I'm ready to put this down for you. I'm going to put this over here. I'm going to write x down. X is 1 over root 2. I'm going to write y down. That's 1 over root 2. And I'm going to write down r. And what's r? It's 1 in this case over here. All right. So I'm going to start writing down what the sine of pi over 4 is. And what's that going to be? Well, it's going to be the ordinate, which is 1 over root 2, divided by the radius, which is 1. So just 1 over root 2. Cosine of pi over 4 is going to be abscissa, which is 1 over root 2 divided by the radius, so it's 1 over root 2. And the tangent, we'll check the answer key later, of pi over 4 is going to be the ordinate, which is 1 over root 2, divided by the abscissa, which is 1 over 2, which is going to be 1. All right, let's look at the key. And, certainly I have x down, I have y down, I have r down, I have sine of pi over 4 is 1 over root 2, cosine of pi over 4, 1 over root 2, and the tangent of pi over 4, 1. Again, we have the picture down as well. I also want to point out, we did put this information down over here, 45 degrees. I do clearly see that, and 1/8 of a revolution. Let's go to the next question. And next question, this is number 3 now. All right, so let's make sure you understand what you've read here. So it says the point 3 minus 4 is on the terminal side of an angle in standard position. So the bottom line is you draw a picture of a circle. It doesn't have to be a unit circle, but a circle centered at the origin. I'm going to say something like this over here. And they tell me there's a point on the terminal side, and I might as well just put it on the circle if I can. And what would that point be? Well, they say it's 3 comma minus 4. Well, x, y down here, x and y. And I hope you realize that 3 comma minus 4 would have to be in the 4th quadrant. All right, so I'm going to say maybe over here somewhere. This would be 3 comma minus 4. This is not a unit circle. I'm going to draw my line in here because it does say this is on the terminal side. And I'm going to talk about the angle now. This is the initial side. What we did was we rotated until we got to this side over here. And I'm going to put that line in for you. Okay. Let's talk about it and stages. All right. So I'm going to write x down. X is 3. I'm going to put the y down. The y is minus 4. And I want to put the r down. And what's the r going to be? Well, it's a circle. So what does it say? X squared plus y squared is equal to r squared. What's x squared? 9. What's y squared? 16. So r squared is 25. Now, if you went back to math 100, they would say r is plus or minus 5. But this is a circle, so r has to be 5. All right. Initially, we don't have negative radiuses. That'll come later in the course, by the way. But right now, r is 5. All right. So it says first draw a picture. I've done that. Determine the values of x, y, and r. I've done that. Determine the quadrant that theta is in. Well, looking at it, I'm going to say this is theta. And theta is in the 4th quadrant, I mean. You can write it down in Roman numerals, or put the word down 4th. Whatever you're comfortable doing. All right, I got that covered. And now it says do all 6 trigonometric functions. Well, I would need to know their definitions according to this picture over here. And they're not asking what theta is, so I'm going to just simply say sine of theta, cosine of theta, yada, yada, yada. So over here, sine of theta. We'll talk about their definitions in a second. Cosine of theta and tan of theta. Now, the sine of theta is going to be the ordinate, which is minus 4, over the radius, which is 5. The cosine of theta is going to be abscissa, which is 3, over the radius, which is 5. The tangent of theta is going to be the ordinate, which is minus 4, over the abscissa, which is 3. Let's write the other 3 down. And they're really easy to do, by the way, because they're reciprocals. The cotangent of theta is the reciprocal of the tangent of theta, so it would be minus 3/4. The secant of theta is going to be the reciprocal of cosine, which is 5/3. We'll check them later. The cosecant of theta is going to be reciprocal of sine, which is minus 5/4. Let's get our red ink out, see how we did. All right, x is 3. I see it. Y is minus 4. I see it. R is 5. I see it. Quadrant, 4th quadrant, I see it. Sine of theta minus 4/5. Cosine of theta is 3/5. Tan of theta is minus 4/3. Let's see, cotan of theta is minus 3/4. Secant theta is 5/3, and cosecant minus 5/4. Okay, we're done with that. Let's go to the next question. All right, this is the next question. All right, a little more complicated, but again, it's going to be really the same thing over and over again. All right, we say the wheels on the bus go round and round. Let's write the theta down first. And the theta is minus 5 pi over 4. I do not see any degree symbol, nor do I see the word, the abbreviation revolution or rotation down. A radian measure then. All right, I'll put this down. So I'm going to write this down, minus 5 pi over 4 times 180 degrees over pi. Well, the pi's cancel off. 4 goes into 180 degrees 45 degree times. So what do I give here? Minus 225 degrees. Put this over here. I'm also going to put revolutions down. So minus 5 pi over 4 times 1 rev in every 2 pi. Pi's cancel off. What do you get? Minus 5 over 8 revolutions. All right. Now, before I go any further, I just want to make sure you understand that this is written down for you. I'm seeing this, I'm seeing this, and I'm seeing this. All right. I'm going to start to visualize now. Now, someone says, why do you need to visualize? Well, hopefully in the future, you're not doing too much work, that you're starting to think about these things. Actually, something you say you should memorize these things. I'm going to say you really need to start thinking. So I'll put my picture down. I'm going to call this X, call this Y, put my circle over here. Again, I'm not very good at drawing circles. I realize that. I'm going to put down, I guess, my initial side right here and my terminal side. How do I do that? I got to locate that. It says it's minus 225 degrees. So I got to start to realize that this thing is being rotated clockwise from that terminal side. So, like if I did that, and again, it might seem complicated to you, but it's really not that bad. I rotate this direction over here. That's minus 90 degrees. That's minus 180 degrees. And I got to go another 45 degrees to get there. I'll put this over here. All right. All right, that's theta. Okay. This is the point in the terminal side. Now, the deal about this one over here, again, we're hoping that you start to realize that there's a reference angle here. And the reference is the angle made with the x-axis. So it's this thing over here. And what is that? Well, I want 225 degrees clockwise. So that would be a 45-degree reference. If that takes effort on your end to figure that out, you want to take the effort to do that. This should not be a guessing game, nor should it be memorization. So what I want to do is I want to draw a picture of a 45-degree triangle. I'm not saying I'm doing a great job of that, but it's sort of like this over here. I think we just did something like that, right? So what's it going to be? This would be 45 degrees, 1 over root 2, and 1 over root 2. All right, let's look at our picture. I want to get this point down now. I'm looking at it. And what's the x-coordinate? It has to be negative. And it refers to this triangle over here. And what's that going to be? Minus 1 over root 2. What's the y? It's a positive number looking at the picture. It's 1 over root 2. All right. What's the r? The r is 1. Let's write this down for you. So x equals minus 1 over root 2, y equals 1 over root 2, and r is equal to 1. Again, r is the radius of the circle. Again, going back to the question, what do they want you to do? Find the values of all 6 trigonometric functions of theta. Let's start writing them down. And they should be relatively simple. So what's it going to be? Sine theta, right, is going to be minus 5 pi over 4. If that takes a lot of effort on your end to write that down, all you have to do instead is say theta is minus 5 pi over 4. Let's erase this now. I don't have to keep writing that over and over again. And I'll put it down for you. And what do you get? Theta cosine of theta. Again, theta is written above as minus 5 pi over 4. Tangent of theta. And the other three is pretty easy to write down. Cotangent of theta, secant of theta, cosecant of theta, the reciprocal functions. What's the sign going to be? Well, I just want to remind you, it's going to be the ordinate, which we've already determined to be 1 over root 2, divided by 1, so it's 1 over root 2. We'll check these later. What's cosine? It's the abscissa, which is minus 1 over root 2 over 1. It's pretty easy to divide by that. And now what's the tangent of that going to be? It's going to be the ordinate, which is 1 over root 2, divided by the abscissa minus 1 over root 2. We did a division, get minus 1. Let's take the reciprocals now. Whichever tangent is the cotangent. So with minus 1 is minus 1. This is going to be minus root 2, and this will be root 2. Let's get a red ink out, see how we did. All right. We got this. I'm seeing it. We've got this. I'm seeing it. 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 All right. Let's go to the next page. And again, I want to point out what we're doing over here. We're just going to work through examples, and this reflects what we've done in lecture. All right. Let's go to number 5. And again, this one, you might look at and say, I don't know where to even start with this. Oh, we start at the same place, and that's drawing a picture of a circle. Not necessarily a unit circle, but I put this over here. And again, I'm not saying I'm doing a great job, but that's my circle. And I can't use the letter X. And so why can't you do that? That's the angle. So X now is an angle. It's not an abscissa, not an ordinate. It's an angle. So I'm going to write down A and B instead. All right, put my initial side down. And now I got to rotate that terminal side. Here comes the tough part. I'm seeing the cosine of X is minus 11/12, and it's between 180 and 270. Now, what does it mean? It's over here somewhere. Right? I may not know where it is, but I know it's over here. Right? It's between 180 and 270. It's over here somewhere. Now, I hope you realize that 12 would be the radius of the circle. So let me, I'm going to erase that X over there. I don't need to see that. I'm going to write down, I know the radius. Oops. I know the radius is 12. Now I'm looking at the minus 11, and I got an A and a B to worry about now. And what's the cosine? It's defined as being the abscissa, and the abscissa is going to be A, so that's minus 11. All right. And then the question becomes, if it's minus 11, it would be over here somewhere, right? Because if this is 12 units over, that would be minus 11. So I'm going to say, looking at it, I'm going to say maybe over here somewhere. I'm going to put that down now for you. Doesn't have to be terribly accurate, by the way. So I'm going to put this down for you. I'm going to say this is the angle, X. And I'm starting to realize I could start to write down some information about the point. And what do I know about the point? I know the abscissa, which is A, is minus 11. And I'm looking at the ordinate, and I definitely know it's negative. All right, I just don't know what the number is. So let's write this down. So it's going to be R squared is equal to A squared plus B squared. What's R squared? 144. What's A squared? 121 plus B squared. I'm going to subtract 121 from both sides. And what would I get? Well, let's see, you'd get 23, right? Equals B squared. And what could B be? It could be equal to plus or minus root 23. All right, I'm looking at my picture, and I clearly know that the B must be negative. All right, so I'm going to cross this out. I'm going to put down B is minus root 23, just by looking at my picture. Not by memorization, but by looking at the picture. So root 23. All right. I can start writing down my answers now, and let me put them down for you. All right. So let's put down sine of x, cosine of x, tangent of x. I'm also going to write down the cotangent of x, which is the reciprocal of tangent, secant of x, reciprocal of cosine, and the cosecant of x, reciprocal of sine. Well, sine is defined as being the ordinate, which is b, over r. So it's going to be minus root 23. We'll check this later, over 12. The cosine is the ordinate, I'm sorry, the abscissa, which is minus 11 over 12. And the tangent is going to be, let's see, the ordinate over the abscissa. So it's minus root 23 over minus 11, which is simply root 23 over 11. Let's write the other three down. They're pretty easy to do. This will be 11 over root 23. This is going to be minus 12 11ths, and this is going to be minus 12 over root 23. Let me get my red pen out and see how we did. Did I get the sine right? Yep, I'm seeing it. Did I get the cosine right? Yes, I'm seeing it. Did I get the tan right? Yes, I'm seeing it. Did I get the cotangent right? Yes, I'm seeing it. Did I get this one right? Yep. Get this one right? Yep. They're all going fine. All right. So let's take a look. Let's do the next one. And again, they tell me theta is 60 degrees. Let's go through this. Write this down for you. Theta is 60 degrees. And we're trying to get familiar with other measures as well. So let me put down 60 degrees times pi over 180 degrees. So that would be, well, the degrees cancel off. You get pi over 3. Let's do revolutions. 60 degrees. There's one rev in every 360 degrees. So that would give me 1/6 of a revolution. You should be able to go back and forth between the various measuring degrees, revolutions, or rotations, and the radian. All right, so what I'm going to do, it says draw a picture. I'm going to do that. All right, I'll put my little picture down. It'll be a great picture, but something like this. Picture is going to be a circle. Doesn't have to be a unit circle. It may be. That's my circle, a great looking picture. And what I'm going to do is, I'm drawing a picture. I'll put the initial side in. And I want to put the terminal side in. And what I have to do, I rotate counterclockwise 60 degrees. You should have a ballpark understanding that 60 degrees would look like this. Let me go to blue. All right, now what does that mean? It means the reference, this is the reference, is 60 degrees. So I got to remember back that we're talking about that triangle. I'll put this over here. All right, I'll put that down for you, 60 degrees. And we derived this pretty easy. It's kind of grade school figure, but you may not remember. If you can't, I want to encourage you to come by during office hours and we can talk about it as much as you like. So 1 and root 3. Well, I'm seeing that now. I'm seeing the triangle. I'm seeing the same triangle. I may have different sides, but I'm seeing it. My question is, what's the point? Well, you could make it a unit circle if you want, but you don't have to. I'm just going to write down what I'm seeing. So I'm going to say the x-coordinate appears to be, and I'll point out what I mean by that, it appears to be 1. And the y-coordinate appears to be root 3. And put that down. And the r, again, looking at this thing, 2. All right. Now what do we got to do? Well, if you can't remember, read the question. Draw a picture. Determine x, y. I can do that. I can do it. All right, I'll write that down for you. X is 1. Y is root 3. Might as well put r down, even though they didn't ask for it. 2. Use the results to evaluate sine, cosine, and tangent. Put this down. Sine of theta, which is 60 degrees. I'll write this over here. Cosine of theta, and the tangent of theta. You'd have to know how they're defined. The sine is defined as being the ordinate, which is root 3, over the radius 2. The cosine is defined as being the abscissa, which in this case is 1, over the radius, which is 2. And the tangent is defined as the ordinate, root 3, divided by abscissa, which is 1, so just root 3. All right, let's take a look, see how we did. All right, 60 pi over 3, 1/6 revolution. I'm definitely seeing that. X is 1, X is 1. Y is root 3, Y is root 3. R is 2, R is 2. Sine of theta, got that right. Cosine of theta, 1/2, got that right. Tan of theta, root 3. We're doing pretty good. Go to the next one. Okay, let's take a look. And it says over here, find 2 solutions to the equation. Yeah, that might be tough. So I got to figure this one out. I got to pull it to the side. Might be a big problem, maybe not. Let's draw a picture. Before I do, I don't like cosecant, so I'm going to write this in terms of sines. And what's that mean? It's just reciprocal function, right? So sine of theta would be minus 1 over 2. I get a better understanding of this now. I'll tell you why I'm saying that. I'm saying if that's the case, R would be 2. I'm going to use X and Y now. And the Y would be minus 1. Well, let me draw the circle, radius 2 now. Radius 2 circle. Let's see, if Y is minus 1, Y would be over here somewhere. Now, I'm going to be honest with you. If I looked at that, the initial side's here, but there's 2 positions where this could occur. Let me put them down for you. One could go through here. Right? Or one could go through here. Okay, let's go through that. All right, let's write this down. Again, I'm not even at the point where I can understand their question. I'm just visualizing what they have over here. And what do I know? I know that r squared equals x squared plus y squared. Well, r squared is 4. I don't know x squared. And what's y squared? Well, if you square minus 1, you'd get 1. So 3 equals x squared, or x could be plus or minus the root of 3. All right, so let's write that down. Let's put our points down now. I'm looking at the picture. And what's this point over here? Remember, I'm looking at the x-coordinate. And the x-coordinate there is clearly negative. And what is it? Minus. Minus what? We just did it, root 3. All right. What's the y-coordinate? I'm sorry, the y-coordinate. The y-coordinate is minus 1. Just over here. Again, I'm not saying it's a great accurate picture, but it's enough for me to understand that it relates to information I know. And the y is still minus 1. Now looking at the picture, I know the x is root 3. All right. All right, let's take a look at it. See if I can figure that out. All right, might be tough, but I want to see if I can figure that out. And oh boy, that's going to be tough, isn't it? Let's put a picture down. I'm going to put a reference down, a reference triangle here. All right, I'm going to put in yellow, something like this over here. I'm going to put it over here now. All right, I'll put these numbers down. I know the radius is 2, right? And I'm looking at a triangle, so I know it's positive sides. And I'm going to say this side was root 3, right? And this thing over here is 1. Gee, that's familiar, isn't it? And what does that mean? That means that this angle here would have to be 30 degrees. I'm recognizing the triangle now. So what's the reference? It's 30 degrees. So I'm going to do this one over here. first. And again, I want to point out to you, the reference is 30. So we have to go 180 degrees plus 30 more. So I'm going to say here, the theta is 180 degrees plus 30, which is 210 degrees. I want to do the other one. Well, the other one is, I'm going all the way around to here. But the question is, what's this angle over here? It's 30 degrees. So you realize if I went all the way, it would be 360, but I got to back off 30, which would make it 360 minus 30, right? Which is 330 degrees. Okay, let me read this to you. Find two solutions. Well, I did find two thetas already. They said, give your answers in degrees. Geez, that's nice. I got them right here. I'll call this the first one. I'll call this the second one. They also say you should give it in this measure, which means there's no unit on it, which means it's radian. So let's write this down. So 210 degrees times pi over 180 degrees. Well, I know it has something to do with pi, right? I'm looking at that. You certainly want to look at that. And I'm going to say 30 degrees is divisible into both those. And so it goes in 7, 6. Let's do the other one. I'll put those answers in box. We'll check them later. Whoops, I need to put the same thing down twice. 330 degrees times pi over 180 degrees. Again, divisible by 30. You would get 11 pi over 6. So theta 1 is going to be 7/6 of a pi, and theta 2 is going to be 11/6 of a pi. All right, let's get our red pen out and see how we did. Well, they said 210 and 330. I got that, degrees, and 7 pi over 6 and 11 pi over 6. We got those right too. All right, let's go to the next question. Again, we're hoping you're following along and you're saying I can do those too. That was number 7. Now we're going to go to number 8, and then we'll do number 9, so forth and so on. I'm going to pull them aside. These problems are requiring a little bit more work, but not much more. I'll get better over time. Let's take a look. It says, find the point on the unit circle. Well, here's the deal. I know it's a unit circle, so I'm going to draw a picture of it. Oops, let's go back to black ink. This is my picture of a unit circle here. Yeah, maybe not great. It's a circle, a unit circle, radius 1. Right, that corresponds to the number t equals 7 pi over 6. Well, let me write this down for you. T, that's the angle now, 7 pi over 6. Gee, that's a mere number, isn't it? Let's write this down. 7 pi over 6 times 180 degrees over pi. Pi's cancel. 6 goes into 180, 30 degrees, and 7 times 30 is 210 degrees. Let's do revolutions. Let's see, there's going to be 1 rev, right, in every 2 pi. Oh, boy, what does that give you? Pi's cancel, so you get 7 over 12 revs. All right, let's just check that, make sure we got it right. 7 pi over 6, 210 degrees, and 7/12 of a rev. We're doing pretty good. All right. Now here comes the problem. I need to locate it. I'll put this down for you. Initial side and terminal side. And the terminal side's 210. So let's start rotating. Counterclockwise, 90, 180. And how much more do I have to go? 30 degrees more. Something like this, where the reference is 30 degrees. Now, granted, this is a very familiar question. It has something to do with a 30-degree triangle. Let's put this down over here. And again, I know it's not perfect. It's really not perfect, but oh boy, I got to put a triangle in, don't I? And let me put this down for you. Let's see, 30 degrees is a reference, right? That's 1, root 3, and 2. You get the idea? All right. But I realize my picture is pretty bad. I got to make it better for you. I'm sorry about that. It's just because you might be confused by my poor picture. I'm not confused by it, but other people might be. Put this over here. Oops, get the black ink. Yeah, it's still pretty bad, isn't it? Put 210 there. All right. And I want that radius. I'll try one here. The reference is still 30 degrees. But I want that radius to be 1. I don't want it to be 2. So I'm going to divide everything by 2. And what would you get if you did that? To my eraser out. This becomes 1. This becomes root 3 over 2, and that becomes a half. Let me write that down for you. I'm going to put my point now. Again, if you're struggling with this, you want to struggle with it. You want to get it right. What's the x-coordinate? And this will be y. Clearly looking at it, it's a negative number, minus root 3 over 2. What's the y-coordinate? Clearly a negative number. What is it? Minus 1/2. What's the r in this thing? The r is going to be 1. All right. So let's see if we've done that. And then we'll go through the work. All right, evaluating the trigonometric functions, cosecant, secant, and cotangent. So let's take a look. Did we get x right? And I want to point out this is x. Did we get y right? And did we get r right? Got this, got this, got this. Now let's do the functions. Although they didn't ask for it, so I'm going to write down sine. Well, this is going to be t, and t turned out, again, if you can't remember, it's written down 7 pi over 6. And this is going to be t. Cosine of t. I know they didn't ask for it. I'm still going to write it down. Tangent of t. And what sine? It's defined as being the ordinate over the radius. So it's minus 1/2. Cosine, abscissa, over the radius, so minus root 3 over 2. The tangent, I'll write this down for you, is going to be minus 1/2 divided by minus root 3 over 2. We did some simple arithmetic over there. You get 1 over root 3. Okay, let's write the answers they want down. They want the cotangent down of t. Well, that's root 3. That's pretty simple. We'll check it later. They want the secant of t. That's going to be minus 2 over root 3. And they want the cosecant of t, which is going to be minus 2. This is what they wanted. All right, let's take a look. See if we've got that. Cotangent, root 3. The secant, minus 2 over root 3. And the cosecant is minus 2. All right, pretty good. All right, let's go to the next one. And again, I'm doing these things over here. Let's see what I got over here. Whoops, sorry about that. Let's put this over here. Let me erase that little extraneous mark I just put in over there. And I'm going to pull another picture out from this. I'll do this thing over here. And let's see. Get these over here. Push everything away. Blow this guy out. And let's see if we can do it. And 9 is going to have multiple parts to it. I guess I'll get the next page here. Before I do that, you know what I'm going to do? Enjoy the picture. I'll put this down for you. Whoops. I'll never get over that, by the way. A little circle down. Again, it doesn't have to be a unit circle, but who knows? Put this over here. And what do they tell me? They tell me the cosine of t is 7/8. What does that mean? It means the radius is 8. Well, let me label these things as being x and y, and it tells me x is 7. All right, I'll put down my initial side. Here comes the tough part, locating that terminal side. And what do they tell me? They tell me this. So I know it's a little kind of confusing to some students, but I would like to know what the degree measure of that is. And I'm going to write this down for you. If you can do it quickly, please do it quickly. So 3 pi over 2 times 180 degrees over pi. Well, pi's cancel. 2 goes to 180, 90. So 3 times 90 is 270 degrees. And 2 pi times 180 degrees over pi, which is pi's cancel, 360 degrees. So where is it? It's between 270 and 360 degrees. Where does that mean? It's in the fourth quadrant. So I know the thing is over here somewhere. I know that much, right? Now, where is it? Looking at it, it says x is 7. If this is an 8 units, a circle of 8 units, 7's over here somewhere. So I'm going to say it hits it about here. I'm not saying it's terribly accurate, but it's good enough. I'll put that down for you. I'll draw this in here. And this is the angle T. All right. Now, of course, I'm looking at the picture, and I kind of know something about this. I know this point over here, and that point over there is going to be what? Let's write this down. It's going to be an x-coordinate, which is 7. I don't know the y-coordinate, though, so let's write this down. X squared plus y squared is equal to r squared. Circle. So what's x squared? 49. I don't know y squared yet. We'll talk about that later. And r squared would be 64. So y squared, let's see, 49 from 64 is 15, right? So y could be plus or minus root 15. But I'm looking at my picture and I start to realize it's not plus or minus root 15. It must be minus root 15, just looking at the picture. Okay, and write this down for you. X is 7, y is minus root 15, and r is 8. Now the first question is, what's the tangent of t? Well, I need to know its definition. What's it going to be? Well, in this case here, it's going to be minus root 15 over 7. Okay. Now, certainly, we're hoping that you're, able to flip a page or two. And I realize if they have letter A for 9, they probably have a letter B for 9, right? And a letter C maybe. Who knows? No, they just got a B. I'll put B down for you. B is sine of t. And what's that going to be? Well, let's write this down. It's going to be minus root 15. That's the y over the r, which is 8. All right, let's look at the answer key. I'm seeing it. And if you flip the page, you're going to see this one as well. Hoping you're seeing both of those. All right, let me flip the page. And we'll go to number 10. Okay, number 10. Put a little box around this one here. And let's talk about it. So it says t equals 120 degrees. I'm going to draw a picture. And as I do that, I think you probably know my pictures are never good. They don't have to be, though. They're abstractions. Try to draw a circle in, sort of like this over here. Good enough. I'm going to say this is x and this is y. T is 120. Let's go through this. If t is 120 degrees, I'd like to know what the radian measure is. So let's put this down. Let's see, there's pi in every 180 degrees. That's divisible by 60 degrees. You would get 2 pi over 3. Let's do revolutions. 120 degrees. There's 1 rev in every 360 degrees. which is going to be 1/3 of a revolution. Let's put the initial side in. It's over here somewhere on the positive x-axis. And the terminal side, what I got to do is I got to rotate now. Counterclockwise, 120 degrees. So there's always something to do with a reference, right? So let's take a look. So if you rotate, you're rotating in this direction. That's 90. This would be 180. I don't want to go, and yeah, I want to go 120. So I have to back off. How much back off? 60 degrees. So let me do that for you. And I'll put that down for you. Something like this over here. So this angle here is 120 degrees. All right. Question is, what's the reference? Well, let's look at it. I'm looking at a picture. The picture looks sort of like this over here. And I'm looking at it. If that's 120 and I'm doing a reference, and that's reference way with the x-axis, this reference triangle would have to be 60 degrees. All right, let me draw a picture of a 60-degree triangle. Looks like that one over there. I think I've seen these before, right? It's 60 degrees. That would be 1. This would be √3, and this would be 2. I'm going to put my point down now. And this is the whole point of drawing a picture. Looking at it, I know the x-coordinate is definitely negative. And what's it going to be? -1. And the y-coordinate, just looking at my picture, is positive. It's √3. All right, what's the r? The r is 2. Let's write this down. X equals -1, y equals √3, and r equals 2. All right, so what does it say? Take t to be 120 degrees. I've done that. Draw the picture. I've done that. Determine what x, y, and r are. I've done that. Use the results to evaluate the 3 trigonometric functions. Well, I think you know what I'm going to do. I'm going to do all 6. Then we'll look at the k. All right, let's write this down. So again, t is 120 degrees. Again, if you can't remember that, go back and read it. The sine of t is something. The cosine of t is something. And the tangent of t is something. Now, what is it? Well, it's defined. How's it defined? Well, the sine is defined as being the ordinate over the radius, so √3 over 2. The cosine is defined as the abscissa, which in this case is -1 over the radius, which is 2. The tangent is going to be √3 over -1, which is just minus √3. All right, let's write down the reciprocals. Cosecant of t, secant of t, and the cotangent of t. What's the reciprocal of the sine function? 2 over √3. What's the reciprocal of the cosine? -2. What's the reciprocal of the tangent? -1 over √3. All right, let's look at our k. I'm seeing the x. I'm seeing the y. I'm seeing the r. I'm seeing the cotangent. Make sure I'm seeing that. I'm seeing this. I'm seeing this. I see the 120. Do I see 2 pi over 3 somewhere? Yep, up there. Do I see 1/3 revolution? Of course I do. All right, so we went through a bunch of examples. And next thing is you got to start doing things, right? You really have to start doing things. So let me just briefly go back and tell you where you are at this point. All right? And just give me a moment. Okay. So again, it's sort of the recurring theme of the course. We cover material. Now, someone said, what did you cover? We covered section 1 of the notes. All right. So we went through that material. Section 1, we're hoping that you've studied that material or at some point studied the material and you're starting to think about it. And then we go through examples that sort of like pounded across about this number 1 material, section 1 material. And then we went through some examples. And of course, at some point, someone said, when do I get a chance to try? We want you to try all the time. All right. Now, again, you may not be ready to try. You haven't studied hard enough. But when you start to study, you say, well, I really need to try problems on my own. And that's why after we go through like this lecture material, we send you off on your own and tell you that you should start doing the supplemental exercises. And that's what's called homework. Right? You work on it, right? And someone says, I can do that. You don't know what you can or can't do until you try it. But after you get through this over here, certainly it's easy to do. I think it's easy to do. You try it. If you need help, though, come by during office hours and we'd be more than happy to help you. Right? After you do all that material in section 1, though, there'll be a web assignment to do. You need to keep reinforcing it. We want you to move forward. We want you to be successful. The only way that's going to happen is if you work towards that goal. All right. Thank you.